Hello guys, this is my presentation, What is Beer? You can find my code at github.com, realsaul00, beer project, uh, beer underscore project. This data set I found from Kaggle, over 70,000 beer recipes, 23 variables. A little bit about beer. As you may know, beer has been around for a very long time. Ales and lagers are the two main types of beers. Um, ABV stands for alcohol by volume. SRM stands for standard reference method, which is color. IBU stands for international bitterness units. OG stands for original gravity, which is the amount of solids. Um, in a beer, more solids translate to more alcohol. BU to GU stands for bitterness to gravity ratio, which is something that I will get to in the next couple of slides. Alcohol by volume. Typical range is from 3.2 to 14. The higher the number, the stronger the beer. Most beers fall right around or below 6 alcohol by volume. As you can see, the density curve is skewed left. Um, like I said, if you go to a brew pub, you would find most beers in the range of about 5 to about 6 alcohol by volume. International Bitterness Units, IBU. When you go to a brew pub, you're probably thinking, what the heck does IBU mean? What is ABV? IBU stands for the bitterness of the beer. Um, Usually, humans can perceive IBU anywhere from 8 to about 120 or so. That's what the researchers say. The higher the number, the more bitter it is. Um, there can be IBUs in the thousands, but humans in reality could not perceive anything greater than 120. So 120 IBU and 1000 IBU would probably taste about the same. Most beers have low to moderate levels of bitterness. As you can see from the density distribution curve, um, most most beers fall in the 20s, 25 to 40 range IBU. Standard reference method, SRM or color. This is how light or how dark the beer is. The higher the number, the darker it is. Typical range is from 0 to 50 SRM. Most beers are amber in color or lighter, as you can see from the chart below. Um, 10 SRM is amber, pale amber color. What else? That's about it on this one. Other features that I had in my data set, boil time. The common boil time is about 60. Brew method, which there were 4 in this data set. All grain, which was the most common. Extract, which was the second most common. Partial mash, and the brew and bag method, which were the least common. Another feature that I had in this data set was mash thickness. Mash thickness was an interesting feature that I decided not to use because it turns out that there were 2 different types of measures, gravity units and also Plato units. As you can see from the 2 spikes in the density plot there, Plato units are the higher numbers, the units greater than 2.5, and the gravity units are in the ones, or are below 2.5. But there was a gray line there. There was some that were Plato, some that were regular units. So I decided not to exclude mash thickness from my data set. for analysis. Features with missing values. There was a lot of features with missing values in this data set. Boyle gravity contained 1,585. Mesh thickness, pitch rate, primary temperature, priming method, and priming amount contain high amounts of missing values. Some were all the way up to 50-60%. Most of them were above 10% with the exception of Boyle gravity. I decided to trim down my data set. I decided to trim it down based on alcohol by volume, something in the range of 3 to 14, which is average, which is what we see out in bars and brew pubs. IBU to 8 to 120 for human perception. OG and FG somewhere in the 0.9 to 1.5. I excluded mesh thickness because of the different units of measures, metric and Plato. I also excluded the variables that had high missing values. The way I dealt with missing values, there was only one feature that had missing value, and that was Boyle gravity, which contained 1,585 missing values of a total of 63,941 total observations. I decided to use linear regression to predict for missing values and to fill in for missing values, just for the challenge and to learn how to do that. I created a function. I used original gravity. Original gravity and Boyle gravity had a correlation of 0.80. Boyle gravity and alcohol by volume also had a correlation of 0.78. As you can see to the right, there is a little bit of my code for that function, which I used to fill in for missing values. What is BU to GU ratio? As I mentioned before, BU to GU tells you how balanced the beer is. If you have OG in your data set and IBU, you can actually calculate BU to GU, which is what I did. I created a brand new column, which I called BU to GU. According to a source, most wheat beers fall between 0.25 to 0.35. Most ales fall between 0.40 and 0.80, and most of your IPAs live anywhere or above 1.0 BU to GU. K-means. I decided to use only numeric features for K-means: original gravity, final gravity, alcohol by volume, international bitterness units, color, boil time, boil gravity, efficiency, and BU to GU ratio. I scaled my numeric features and determined the number of clusters, which I decided to use 6 clusters. I started with 8, I went down to 5. I decided to stay with 6 clusters. I set my seed to 1, 2, 3, and my end start to 20. And as mentioned before, I decided to use 6 clusters for this particular example. When I plot alcohol by volume versus IBU, IBU being in the y-axis, ABV being in the x-axis, you can clearly see that cluster number 2 has the highest levels of alcohol. There's clear separation there. In terms of IBU, in terms of bitterness, it is full range. Another cluster that stands out clearly is number 6, with low to moderate levels of alcohol content and high IBUs. Cluster number 4 is moderate in terms of alcohol by volume and low to moderate in terms of bitterness. Cluster number 1, low alcohol by volume and low bitterness units. BU to GU ratio versus color. There was clearly a cluster number 6 that stand out here with most BU2GUs in the highs over 1. This is probably the cluster that has most of the IPAs. Boil time versus original gravity versus by clusters. This is one of my favorites because it illustrates the power of k-means. Here we have cluster number 2, high original gravity. Once again, original gravity is the amount of solids. The higher original gravity, the higher the solids. The higher the solids, the higher the alcohol that is produced. Cluster number 3 as well has high boil times. Moderate to high boil times, low to moderate original gravity. Cluster number 1 is also pretty, you could clearly make out where cluster 1 is. It lives in the low to moderate boil times and low original gravity. And cluster number 4, low to moderate boil time and moderate original gravity. Efficiency versus color. In terms of clusters, here we can clearly see that cluster number 5 has the lowest efficiency. This was the high driver for this particular cluster, for cluster number 5. BU to GU ratio to original gravity by clusters. Once again, as expected, you can see cluster number 2 with high original gravities. Full range of BU to GU ratio. Cluster number 6, high BU to GU ratio and low to moderate original gravity. Cluster number 3 had low to moderate levels of BU to GU and low to moderate OG. And cluster number 1, low to moderate BU to GU ratios and low original gravity. Cluster number 1, I called it the light and common. Very, very common beer, easy to drink, low alcohol content, low bitterness levels, and light in color. It is the largest cluster group. As you can see, some of the common words for this cluster: saison, wheat, clone, blonde, amber, brown, APA, red. As you can see, it is very, very light in terms of alcohol by volume, bitterness, and color. Cluster number 2, I call this the strong, bitter, and dark cluster. Completely different than the other cluster, strong and bitter. Full range of colors, but usually dark. Higher boil times than original gravities. As mentioned before, original gravities translate to more solids, and more solids produce more alcohol. As you can see, alcohol by volume is 9.52 compared to 5.25 from the previous cluster, which is twice as much. Bitterness units is at 60 compared to 30 from the previous, so twice as bitter as well. Cluster number 3, I call this the flavorful and light cluster. This one is very similar to cluster number 1. The only difference is the higher boil times, which usually translate to more flavors. Some of the key words in this cluster, when I use text analytics using Python, you got the word bake, brig, pills, brown, summer, blonde, pilsner, and so on. Cluster number 4, I call this the just perfect cluster. Happens to land in the happy zone. Not too light, not too strong, not too mild, not too bitter. Full range of colors and aromas. Interesting words that came out of the text analytics, such as chocolate, oatmeal, pumpkin, smoke, brown, black, milk, coffee. This cluster is pretty interesting. It would be something that I would definitely love to try. Beginner's Brew, cluster number 5. This cluster had low efficiency. When I analyzed it further, I noticed that low efficiency translated to the extract method, which is quite common in this cluster. This cluster is all over the place. When I researched extract method, it is quite common for beginners to use the extract method. So I call this the beginner's brew, which is probably why this cluster is all over the place. Cluster number 6, my favorite, hoppy and balanced. This is where most of the IPAs live, flavorful and full of aromas. Um, Interesting words that come out of this cluster like Citra, Dipa, Nipa, Summer, Stout, Black. This cluster is very, very, very hoppy. High bitterness units, but it is highly balanced, so you cannot perceive the bitterness, full of aromas. This is by far my favorite cluster. How do they compare? Light and common, cluster number 1, it's in terms of alcohol by volume, it's light. Bitterness bitterness, it's low. Color is light. Cluster number 2, strong, bitter, and dark, is strong, bitter, and dark. Cluster number 3 is the exact same thing as cluster number 1, with the exception of the high boil times and perhaps more flavorful. And in terms of the difference between cluster number 1 and number 3, cluster number 4 is just perfect. It just happens to have land in the Goldilocks zone, mild to semi-strong in terms of alcohol, low to mild in terms of bitterness, light to dark in terms of color. Cluster number 5 is all over the place. The only difference between this cluster and the rest of the clusters is the fact that it has low efficiency. Extract method is quite common in this cluster, and this is why I call this the beginner's brew. This cluster is all over the place. Cluster number 6 is hoppy and balanced, mild to semi-strong in terms of alcohol, bitter to balanced in terms of bitter but balanced in terms of bitterness, and light in color. This is by far my favorite cluster. This one and number 4. Anyways, that wraps up my presentation. Thank you very much. Have a wonderful day.